Okay, so just as a reminder, one more time for the camera, you're gonna need to make sure you have those reference tables from the syllabus. They are required for this class. If you cannot get them, you need to send me an email and I will have a copy for you to pick up in the front office, but they are needed ASAP. Okay, now, so let's start the new lesson today. Today we're gonna focus on the electrons. I think I have beat with a stick the nucleus, the protons, the neutrons, atomic number, mass number. Hopefully, if you were feeling shaky on that, you were able to tune in the last 2 days, because I think I really went over and over and over that. But again, if you're still iffy about that, then that means that you need to be contacting me for a one-on-one. Maybe we just need to sit together, and rather than doing it in a whole group setting, we could schedule some time to work with you to see exactly what it is you specifically are missing in that, okay? So what I'm starting on your notes today is I'm going to start with the electrons. Now, I touched on those just a little bit, so I'm going to do a quick review of what I've already said about electrons, and then I'm going to move into the new information. Okay, so electrons are the negative particles. Now, the one thing I did not mention is their size. If you remember back from the other class, a proton and a neutron are roughly 1 AMU. As a matter of fact, a proton is exactly 1 AMU, and a neutron is pretty close. You know, as my grandma would say, just a hair off. So really, 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 really close. 1 AMU, let's just call them both, all right? But now an electron, way, 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 way smaller, okay? So please understand that when we are comparing the mass, the size of these particles, that an electron is so small that we don't even consider it when we're talking about the mass of an atom. So remember, how do we get mass? We add up only the protons and neutrons. Guess what we just totally did not include? The electrons, because no matter whether there's 10 of them, 5 of them, or 105 of them, they do not affect mass. Mass say no to the electrons. And I might try to trick you. I'll go ahead and tell you right now that there might be a test question or a quiz question that says an atom has 10 protons, 10 neutrons, and 10 electrons. What is the mass? You better not be adding in those electrons. What are the only 2 particles we need to be adding together? The protons and the neutrons. So the mass would be 20, not 30. Be careful about that. All right, the other thing we talked about electrons is they're basic, and y'all, this is basic, how they're distributed within the energy levels. We said in the first energy level that is closest to the nucleus, we can put a max of 2. We go out to the second energy level, we can put a max of 8. But when we get to the third energy level, this is where it gets a little wonk, wonk, okay? Because when you get to the third, although it has a capacity for 18, it has a spot for 18 electrons. We rarely, now I didn't say never, but we rarely ever put all 18 electrons in that third energy level before we move on to the next. Instead of filling it, what we do is we just satisfy it. And once you hit the third energy level, rather than trying to fill it, you're trying to satisfy it. And 8 electrons will satisfy an energy level, allowing you to maybe move on to the next. Now, there's going to be times we do, and there's going to be times we don't. But the more we practice constructing atoms, I think it'll start making sense to you. All right. The last thing we've already talked about when it comes to electrons is we talked about how the number of electrons is equal to the number of protons. The negatives equal the positives in an atom. So atoms are always electrically neutral. And I listened to my little video the other day. I know I said that at least like 11 times, okay? Atoms are always electrically neutral, which means that the negative has to equal the positive to balance out. But what we also learned was that although atoms may be neutral and balanced with their protons and electrons, that doesn't mean they're happy. That doesn't mean they're stable. That doesn't mean that's the way they want to live their life. So what has to happen is, in order to get happy, in order to become stable, that atom will either gain or lose some of its electrons, specifically the ones on the very outside shell, whichever shell that is, whichever one is on the outside, that is the one that they will gain or lose from. Now, when you start gaining and losing electrons, it ain't matching the proton number anymore. You changed it. So we no longer have an atom, because remember, atoms are neutral. If we've gained or lost electrons, we now have a charged atom, which is an ion. So an ion was an atom that gained or lost electrons, no longer neutral, it has a charge. So if you've opened your quiz yet that I gave you for Tuesday and worked on that, you knew that the last two questions like I said, I kind of stretched it a little bit. I kind of gave you a sneak peek on what was to come. And I did that for 3 reasons, and I feel pretty good about why I did it for 3 reasons. Number one, you have all the notes. So it might challenge you to even kind of look ahead to see what we're talking about next and see if you can kind of figure it out on your own. This is honors chemistry after all. That's my other reason, number 2. So you are kind of expected to just go beyond the basics, all right, or what I've given you that day. You are to look beyond. So that's reason number 2, honors chemistry. Reason number 3 is because all of my quizzes, you can edit them. You can retake them. So even if you might not have known that day about those last 2 and how to handle those, and even if you tried to look ahead and just wasn't 100% on how to do that, understand that by the deadline, by Friday, when that quiz is due, I'm going to be teaching that. So that encourages you to try, ask questions about it in our practice sessions to try to figure it out. But know that before the deadline for that quiz, I'm going to be covering that, okay? So there's my 3 reasons why I think it's okay to maybe push the envelope a little bit and give you something a little beyond what I've already talked about. And the last 2 questions did that. So what I'm going to actually do, this is a page from your notes, okay? So what I'm going to do is I've already talked about electrons in general. I've kind of touched on valence, just like what their definition is. I'm actually going to jump over here, and then I'll come back to valence before we end today's lesson. But for right now, I'm going to kind of jump over, since these problems were very similar to the ones that you had on the last 2 questions on your Tuesday's quiz. All right, so what we have here, and I hope you can see me, I'm going to kind of... So let me know, because I have 2 cameras open. I have my phone camera that's recording, because I cannot record the Google Meet, and then I have the Google Meet camera on my computer. Can my Google Meet kiddos, can y'all see this and me? Can I just get someone say yay or nay? Yes, good. All right. So this would be like maybe 2/3 review and 1/3 new stuff. So what you've learned how to do already from the previous lesson was you learned how to look at this given information that describes an atom and how to determine the number of protons, how to determine the number of neutrons, the mass number, right? So when I look at this, what should you know? You should know that this is sodium because that's the symbol for sodium, and as soon as you get a periodic table, you can be real sure of that because you can just look it up, okay? You should know that this number right here represents two things. It's the atomic number, which also represents the number of protons, okay? So this number in this bottom position will always represent its atomic number, which matches its box on the periodic table right here. And if you can see, sodium is right here. I don't know if you can see that well. It's number 11 right here, okay? And so that is number of protons and the atomic number. Now, this top number here, in all cases, is your mass number. Remember, mass number is the sum of protons and neutrons. So collectively together, the sum of protons and neutrons in the nucleus equal 23. Now, from this also, you should be able to get the number of neutrons. Because if this is the protons and neutrons added together, and this is just the protons, then all we got to do to get the neutron number is to say the mass number minus the proton number. So 23 minus 11 gives us what? Like 12 neutrons. All right? So that's our review. That's stuff we've already talked about. But now I want to focus on this because what this little number in the corner is going to do is tell us about our electrons. Now, look at me in the eyes. This number does not tell you how many electrons you have. It just tells you if and how the electron number has changed. So that little number up there is not saying, oh, I got this many electrons. It is saying, hey, the electron number didn't change, or yeah, it changed. I either gained or lost some, okay? Now, so if this number wasn't there, which is what we saw in the previous lesson, if there is no little plus or minus number in that corner, it is just empty space, then that means that this is an atom of sodium. And if it's an atom of sodium, that means that it's electrically neutral, and the number of electrons has to absolutely match the number of protons. So in a neutral atom, meaning there's no charge showing, then if there's 11 positives, there would have to be 11 negatives. But there is something up here in the corner. So that's letting me know that my electron number has changed. It no longer matches my proton number. Now, what does this mean? So let's do a little quick thing here. Notice that all of these will either be plus or they'll be minus. So let's talk about what that means. A plus charge is telling you that you have lost electrons. Now, I know that's a little freaky. I ain't even gonna play, okay? Because you've been taught your whole life that a plus sign means you've added, right? So you immediately think, oh, plus gain, I got more. No. We are dealing with electrons, and electrons are little pieces of negative charge. So if you lose negative charge, that's what makes you more positive. If you lose negative charge, you become more positive. Think of it like negativity, like, ooh, like she's so negative, okay? So if I'm a negative person, I'm so negative today, it's horrible, it's too early, I hate this virtual school, okay? If all of a sudden I lose that negativity, then I become more positive. It's a wonderful day, okay? So that is what we mean. If we lose negativity, which is what happens when we lose electrons, then we become more positive, and ions do the same thing. Now, a negative sign means you have gained electrons, okay? So anytime you see a negative charge up in that corner, you have gained electrons. You have gained negativity. So let's just say I'm having an okay day, and all of a sudden gain a bunch of negativity, then I'm going to become more negative, right? So if you gain negativity, meaning you gain electrons because they're negative, then you will become a negative ion. So gaining electrons turns you into a negative ion, and losing electrons turns you into a positive ion. So remember, an ion was an atom that gained or lost electrons. And specifically, they lose them from the outside, okay? Now, your notes tell you a little bit extra. They tell you that if you are a positive, if you're something that has a positive charge, not only are you a positive ion, but there's a name for that. And it's called a cat. Meow. A cation, okay? And if you have a negative charge, like this one does, then you're called an anion, A-N-I-O-N, anion. So this would be an anion, these would be cations based on their charge. Now, so what I'm going to do now, and again, if you tuned in yesterday, we talked a little bit, we did a few of these just because, you know, why not? But we're going to talk about how to use this charge to figure out the number of electrons. So what we've said already in this, that there's 11 protons, there are 12 neutrons, and now we're trying to figure out the electron number. All right, so I look up here and there's a charge, which means, whoop, there's been a change. And a plus sign, if you remember, means that I have lost. How many did I lose? Oh, 1. I lost 1 electron. Now, I will tell you that sometimes you will just simply see the plus or the minus sign. And if that is the case, then 1 is understood, okay? Sometimes they write the 1, sometimes they don't, okay? So this tells me that I have lost 1 electron. So remember, how much did I have as an atom? Well, if I had 11 positives, I had 11 negatives. But I have lost 1, so that takes me to 10 electrons. Again, I know I've said it a lot. If at any time during this, it's kind of hard for me to read the comments while I am teaching, and make sure that I'm in the frame and everything that's up here you can see. So sometimes I might miss that. And I realize that you might not necessarily care to speak up, but for your own benefit, you know, you don't even have to identify yourself. I think I'm the only one who can see who's speaking, but I'm not sure. I mean, you don't have to show your picture either. But if there's something that I'm presenting and you're lost on in the moment, I'd appreciate it if you would just stop me. Okay? Because if you'll stop me, we'll fix it. All right? Okay, and you just be like, yo, hold up, put the brakes on. All right. Now let's move on to this one here. And I'm going to do the exact same thing I did here. So I'm just going to erase these, and then I'm going to fill them in for each one. So, proton number. Remember, the bottom number down there, which is the atomic number, is also the proton number. So 13 protons. Neutron. Yeah, well, let's move to mass number. Mass number is the number in the top, which is 27. To get the neutrons, remember, I have to subtract out those protons from the mass. So if I say 27 minus 13, I get 14 neutrons. Last but not least, the number of electrons. So remember, if this was not there, I would say, oh, the number of electrons has to equal the number of protons. There's something there that says, hold up, we've made a change. A plus 3 means that we have lost 3 of our electrons. So instead of having 13 that I would have in an atom, I now have 10. I went from 13 to 10, and that's why I am an ion, because my protons and electrons don't match anymore and balance out. Do you agree that if I have 13 positives and only 11 negatives, that I am more positive. That's why I have a positive charge. How many more positive am I? I'm 3 more positive. That's what that means. All right, let's move on to our last example of this for today. Again, we're doing protons, neutrons, and electrons. And this time we're doing it for the sulfur. All right, so again, the bottom number is always the atomic number, which is the number of protons. So I have 16 protons. Now, the mass number is the number on top. Please do not ever think that this number on top is your number of neutrons. It is not. We're just going to use it to find our neutrons. And so all I've got to do to get my neutrons is say this mass number minus the atomic number. So 35 minus 16 is, oh gosh, help me. 16 and 16 is 32, 17, 18, 19. Is it 19? Yeah. 19 neutrons. I hope. All right. Now, let's move on to our electrons. Again, nothing there, blank space, then hey, sulfur atom. So if there's 16 of these, that would have to be 16 electrons. But no, because there's a charge here. And if you remember, a negative charge means we have gained electrons. And in this case, we have gained 2 electrons, which takes us from 16 to 18. All right, so that's how we look at this type of notation and not only be able to tell me the protons, the neutrons, but also determine the electrons as well. Whether there is no charge at all, meaning that it's a neutral atom and they match the protons, or whether there is a charge there, letting you know that the number of electrons have been gained or lost. Okay, now, what I'm going to do now is I'm going to go back over to this side of the notes, right above the periodic table, and I'm going to talk about this section real quick, because the periodic table, you will find out very quickly, is nothing that was thrown together on a Thursday afternoon, okay? The amount of information that you're going to be able to get from the periodic table just simply based off the location of that box is going to pretty much amaze you. Okay, so please know that there's a lot of time been put into this thing and how it works. So what I'm going to do now is I'm going to hit on some stuff about valence electrons. So if you remember, we have the nucleus. This nucleus is made up of protons and neutrons, right? And then we have energy levels. 1, we might just have 1, we might have 2, we might have 3, we might have 4, but when we put our electrons in, when we get to the very, very last energy level that's wrapping around the nucleus, whether it's the first one, whether it's the second one, whether it's the third one, whichever one is the last one, that is called your valence shell, all right? V-A-L-E-N-C-E. And that is the very last. Now, it's not, I'm pointing to the 4th, but it doesn't mean it's the 4th. It just means it's the last one, and that's the last one I drew, okay? Any electrons that you place here in this outermost shell are the most important electrons of all. As a matter of fact, the ones on the inside are referred to as the core electrons because they're closer to the inside. But it's the valence electrons that do all of the coming and going and sharing and gaining and losing. They're the ones that it's the job of these valence electrons to make that atom happy, okay? So in this beginning lesson, we're only going to talk about gaining and losing from the valence shell. But eventually, when we start talking about bonds, we're going to talk about how they can be shared as well. But right now, we're going to focus on gaining or losing, okay? So in order to get happy, the electrons in the outer shell can either be gained, you can either gain more to it, or you can lose what you have, okay? All right, so let's see what I got here. A valence electron number determines how the atoms will react. So depending on how many valence electrons we put there, we can then look at that number and decide, is it going to gain? Is it going to lose? Is it going to do nothing? Just by looking at the number, okay, of how many we put there. All right, so let's talk about this. Why does an atom want to gain or lose valence electrons? Like, why? Why can't it just be happy with the way it is? Why does it want to gain or lose? It wants to gain or lose so that it can have eight electrons in its outside shell. Its valence shell is only happy if it has 8, okay? Now, there is going to be an exception to that, and that is, well, what if the first shell is the outside shell? Can we put 8 in the first shell? What's the most we can ever put in the first shell? 2, perfect, right? So the only exception to being happy with 8 is great. The only exception to that is the first energy level. If that is your outside energy level, then you can never put 8 in it. It's going to be happy with being full with 2. But like, as I told you earlier, the third energy level, if that's your outside energy level, although it has a capacity for 18, we're going to, if it's our last one, we're going to make it happy by making sure it has 8. So every atom's goal to be happy in life, to be deemed successful, is to have 8 valence electrons, 8 electrons in their outermost shell, okay? Now, in order to get that atom's going to have to either lose some of its electrons or gain electrons in order to hit that magic number 8 and have a happy valence shell. So, let me first of all show you the quickest way in the world to figure out how many electrons are going to end up in the valence shell, okay? Without drawing it, because I could sit here and I could draw it, right? Like we did in our first lesson, right? And I could put, if I knew something had 11 electrons, then I could take those 11 electrons, put 2 in the first energy level, put 8 in the second energy level, and then that would be 10, and then I'd have 1 more in the third energy level. And I would know that I had 1 valence electron, okay? But there's a much easier way to know rather than drawing them all out, which we are going to draw, but there's a much easier way. And that, my friends, is dealing with the periodic table. So let me get you on this periodic table here. Let me get my camera on the periodic table here. Sorry, I'm getting there. Okay, I think I'm here. All right. Now, do you see all of this and me? Somebody? Tell me? Yes, okay. So, the periodic table, as you can see, is made up of all of these columns. So columns, just like the columns on the front porch, right, go up and down. And each one of these columns is considered a group. So, you're going to need to know that when we talk about the up-down columns, we're talking about groups. Okay, so the columns are the groups on the periodic table. Now, if you've had a chance to print out the one that we have, you're going to see that above each of the tall columns, they're what we call A groups. So if you look right there, I don't know if you can see it or not, there's a 1A, Roman numeral 2A, Roman numeral 3, 4, 5A. Do you see that? Okay, so these are your A groups, the tall columns. The ones in the middle here are our B groups. Now, B groups are more unpredictable. So we're going to be skipping the B's because everybody wants an A, okay? So we're going to be just ignoring the B group for now, okay? And today we're going to focus on only the predictable A groups. So this is 1A, 2A, and if you know your Roman numerals, that's how they're shown on your periodic table. A Roman numeral 1A, 2A, skip all the B's, 3A, 4A, 5A, 6A, 7A, 8A. So it's just simply 1, 2, 3, 4, 5, 6, 7, 8, and all of those are A's. Did you know that you just figured out? That is how you know how many valence electrons end up on the outer shell, okay? So that means that every single element, every single atom you see in group 1, hydrogen all the way down to francium here, that when you draw its atom, you will end up with 1 valence electron. So these have 1 valence electron. I'm just writing 1 val E, okay? 1 valence electron. They all do in that group. Now, let's go to the second group. Take a wild guess. Guess how many valence electrons they have? Dos. So these have 2 valence electrons, all right? Again, we're skipping the B's. We're going to come over here to group 3A. And group 3A, we'll change pens just so it may be a little darker. These have 3 valence electrons. Take a wild guess. 4 valence electrons. 5 valence electrons. 6 valence electrons. 7 valence electrons. And 8. Bam, bam, bam. We hit the bingo. Remember, this is what they all want. 8 valence electrons. So without drawing a single atom, remember, the valence electrons are what matters, right? They're what's going to tell us whether this atom is going to gain or lose electrons. What is it going to do to become happy? Is it going to gain? And if it gains, is it going to become a positive ion? Or is it going to lose? And if it loses, it's going to become a negative ion. We can know all of that by simply knowing what group our element is in. All right? So that means that if I point to any element in here, I know I have 3 valence electrons. Any here, 7 valence electrons. Okay. So before I move on with this topic, I want to say this. Remember I told you that the magic number, what every single atom wants, is to have 8 in its valence shell. Unless, of course, it's the first, they can't hold 8, okay? But in the outermost shell, the goal is to have 8 valence electrons. And as you can see by looking here, nothing has 8 except that very last group there called the noble gases. They are the only ones that have what every atom wants. So there is no need for them to gain or lose, which is why they don't ever become ions, because the only reason you become an ion is to hit 8. And guess what? They already have 8. But every single other element on the periodic table does not have the 8, which means that every single other element on the periodic table has to gain or lose electrons from their valence shell to be stable, to be happy, to be like a noble gas, to have the same number of electrons, valence electrons, as a noble gas. Okay? So what we say is that all of these want to achieve a noble gas electron configuration. That's the fancy words for they all want to get 8 like the noble gases. So now we come to how do they get 8? Remember, they gain or they lose, right? So here is your rule. Write this down. It's in your notes, but write it down again. All right? If if an element has less than 4, if you have less than 4 valence electrons, which is everything that has 1, everything that has 2, and everything that has 3, less than 4, okay? Then you will lose them. They will lose them, okay? If you have less than 4, you will always lose your valence electrons. So, remember, what charge is lose? Isn't lose a positive charge? If you lose electrons, you become positive. So let's talk about that. That means that we're going to create a charge. So if you remember over here on our board a while ago, everything that we were dealing with had a charge, like sodium was a +1, aluminum was a +3, sulfur was a -2. Those charges don't change. They are the same all the time. I'm going to teach you how to use the periodic table to figure out what that charge will be, because sodium's charge is always going to be sodium's charge. All right? So, because this group right here, group 1, has 1 valence electron, and the rule says if you have less than 4 and 1 is less than 4, you will lose them. The charge for anything in this column will always and forever be +1. I'm going to change my pen just so it shows up better. +1. That means when any of these things become an ion and has a charge, that's what the charge is going to be. Which means to get happy, they had to lose, plus is lose, 1. All right, anything in group 2 has 2 valence electrons. That's less than 4, so that means they will lose those 2. And the charge that says I lost 2 is a +2. So the charge for anything in this group will always and forever be a +2. All right, now let's come over here real quick. All right, remember we're skipping B groups. 3 is less than 4, so they're going to lose those 3. How do you say I lose 3 electrons? You have a +3 charge, okay? Now, remember this says less than 4, okay? Our next rule is going to be if you are more than 4 valence electrons, you are going to gain electrons. I'm going to take them off and just put electrons just so you will gain electrons, and that will give you a negative charge. So if you notice, if you are Johnny on the spot, you notice I have skipped number 4. I said if you're less than 4, you do this, and if you're more than 4, you do this. That's because 4 has an unpredictable charge. I just put a big old X on it, and we don't assign a charge to those. That is going to be something we'll talk about later when we talk about our B groups. But for now, assigning sure thing charges, we're skipping group 4. Now we're going to be following this rule. If I have more than 4 valence electrons, I'm going to gain. Now listen carefully. Look in my eyes. When I say you gain electrons, you gain just enough to equal 8. So if you have 5, you don't gain 5, you gain 3 so you can get to 8. Does that make sense? So when I say gain, don't mean like, oh, I will gain that many. No, you gain just enough to get to 8. All right, so I'm going to put, we'll just go to group 5. So if you're in group 5, you have 5 valence electrons. That's more than 4, so we're going to gain to hit 8. And if you're at 5, you gain to gain 3 more, right? So if I gain 3, that is a -3 charge. Gain 3, -3. If I have 6, I'm going to need to gain 2. So those are going to have a -2 charge. If I have 7, I'm going to need to gain 1. So I'm going to have a -1 charge. And if I have 8, I ain't gonna do a ding dong thing because I already have 8. So they have no charge whatsoever. They don't gain and they don't lose because they don't need to. Okay? So it would do yourself a very, very, very big favor just to understand, not memorize. This is not about memorizing, but just understanding that there's basically a pattern here. These have 1, they lose 1. These have 2, they lose 2. These have 3, they lose 3. Then we cross over and we ignore the 4th. 5 has 5, so they need to gain 3. 6 has 6, gain 2. 7 has 7, gain 1. And just understanding that basically it goes uphill, +1, +2, +3, hit the top of the tree, then come back down, -3, -2, -1, 0. Okay? +1, +2, +3. 4th group, nothing. -3, -2, -1, hit the bottom. Okay? All right. Now, I want to see, there is one more thing I want to talk about with the periodic table, and then this lesson will be over, but it's very important, and it will help us with our lesson on Monday. Okay? So, Monday. Monday's our next lesson. So, one other thing I want to talk about with the periodic table. You know, I've been talking about the energy levels, right? And basically, you know, how many valence, you know, what is its valence shell? Is the valence shell the first shell, the second shell, and so on. So, what we know so far is that the up-down columns represent the groups. And the groups tell us how many valence electrons it has, as well as telling us how we can also figure out from that the charge, like what charge will it be when it becomes an ion? Does it gain or does it lose, and how many does it gain or lose by looking at its charge? The other thing that we get from the periodic table, when we go across a row, all right? So when we read across all the way across 1, all the way across 2, all the way across 3, across the row, these are called periods. And the periods tell us how many energy levels surround that nucleus. So for example, if I were to go to sodium, okay, and sodium is a group 1 element, and I were to count down, hydrogen's number is in the first row, lithium's in the second row, and sodium's in the third row. Because sodium's in the 1, 2, 3rd row, that tells me that sodium will have 3 energy levels surrounding it. The last energy level will be the 3rd energy level. And guess how many electrons we're going to put in that last energy level, which we call the valence? 1. So all you got to do is to read across whatever row your element is the number of shells, and then the number of the 1A, 2A, 3A that lets you know what group you're in is how many electrons go in that last shell. All right? And again, what the charge is saying is that I was an atom, but I wasn't happy and I wasn't stable. And in order to get happy and to get stable, which means I want 8 electrons in my valence shell, then I either had to add some electrons to get to 8, or either I had to lose some electrons to get rid of that incomplete shell. And this is the rule of thumb you need to follow so you'll know that. Okay, I'm going to end today's lesson. What we'll do on Monday is we will pick up, and where it says construct atoms down here, we're going to be constructing atoms on Monday, putting together everything we've learned this week about the structure of atoms, and hopefully bringing it all full circle. Okay? All right, so I'm out. But if you have questions, feel free to stick around and ask.